Hello, this is a continuation of our series where we look at working with Codesys Control for Raspberry Pi. And in today's tutorial, we are going to look at how to work with I2C. So like we mentioned already, when you look here at our device tree, we have various interfaces that we can use to connect to different devices over different industrial protocols. Last time we looked at how to work with GPIOs, and we saw how we can read digital inputs. But today we are going to look at briefly at how to work with I2C. So first, the environment that I have here, I'm working with Codesys 3.5 Service Pack 20 Patch 5 32-bit version, and the Codesys Control runtime for Raspberry Pi. I can show you the version that I have here as well. So I am using the Codesys Control for Raspberry Pi MCSL 32-bit version there. It's version 4.13. So I'll first connect to my Raspberry Pi and check that my runtime is already running. And if it's not running, I should start it. So all I need to do is come here to Tools, go to Deploy Control SL. And then from here, I can enter the Raspberry Pi IP address, and then the username here, and then the SSH username, and then the password as well, password. And then I attempt to connect to the Raspberry Pi via SSH. And there you are. So I'm connected. And then when I go under operation here, I should see, make sure that both your Codesys Edge Gateway for Linux is running, and then Codesys Control for Raspberry Pi is also running there. If none of this is running, or if one of them is not running, you can just click, and then you can press on Start Selected so that you can start that particular service. So our runtime is running, and we can also attempt to connect to our Raspberry Pi. Then I just come here, scan network, select my device there, and then I click OK. And then enter my device management username, and then device management password, and then click OK. Okay, and now I'm connected to my PLC or Raspberry Pi for that case. Now, to use I2C to connect to devices and read and write information over the I2C protocol, we will be working with this I2C interface here. So to start, we need to add what we call an I2C master. So right-click on that, go to Add Device, and then select I2C master from the list here, and then add that I2C master. And now we can close this. Now, one thing to note about I2C in Codesys here is, unlike the protocols, for example, Modbus, which defines the server data buffers and the functions to read and write data to those buffers, call them registers. I2C is kind of different. Each vendor will define, each device vendor will define their own data buffers and the mechanism of how to access data and read data from those buffers and write data to those buffers. So there is no out-of-the-box driver that can apply to all I2C devices, as is the case with, for example, Modbus or Profinet or other protocols. So that means that each device must have its own separate driver. So there is no one standard driver for all I2C devices. Each device must have its own driver. So I can show you here, for example, when so the devices are added to this master, and then you can then communicate with the device. So if I right-click here to add a device, so right-click to I2C master, go to add device, you see that there's a list of devices here. So Codesys, when you install the runtime packages, it will install some drivers for some devices. So for example, you see here there is this Adafruit PWM is a separate I2C device. There's this Gyro MPU 6050 is another I2C device. So each device, each I2C device you want to communicate with must have its own defined drivers. So Codesys cannot define all the drivers for all the I2C devices out there in the market. There are thousands of devices. So they can define so many. And you can see here that they've defined just a few. That is up to 8 devices. So that means that if you have an I2C device that is not on this list, you must define a driver for that device before you can connect and communicate with it. So for our case today, we are going to see how we can connect with this ADS1115. It's an analog to digital converter. It's a popular I2C ADC converter. There it has 4 channels, and we shall see how we work with it and how we can connect to it and read data here in Codesys. So I can show you a little bit of the setup that I have, and then we can continue. So the driver for that device is not on this list, so I've developed a driver for it already. So we shall see how we can go over how to install the driver and then set it up and then communicate with the device and read and data from the device. So I'll close this here, and I'll show you briefly here a little bit of the overview of the device. So it's a popular ADC chip here, as you can see. It has 4 channels, like I've said already. It has some pins, extra pins here. This you can set different addresses to the device so that you can, for example, connect up to 4 I2C, 4 devices on the same I2C bus. We are not going to use that option now. It has a default I2C address that is 48, I think, in hex. It has this VDD and ground. Those are for the supply. And then it has this SCL, the clock, and SDA, and the data lines there. So you connect the VDD and ground there. So we're going to connect the 3.3 to the VDD, ground to ground, and then the SCL, and then the SDA, and then we shall be reading data from channel 0 here. So what I've done, I'm using this potentiometer to generate for me some analog signals. So I've connected the out of the potentiometer here to channel 0 there. So we should be reading a value from 0 to 3.3 over this channel 0 here. So that's the device here. That's the connection that I have. You can see here that I've also not highlighted which pins I'm connecting to on the Raspberry Pi. So I'm working with a Raspberry Pi 3B, and if I pull up the pinout diagram here, so we have the pinout layout here, as you can see. So I'm using this GPIO2. So I'm using I2C1, GPIO2 for SDA, GPIO3 for SCL, and then 3.3 is my VDD. It goes to the converter. It also goes to the potentiometer, and then the ground as well goes to the converter and to the potentiometer as well. So as you can see here, so the VCC or VDD comes from the Raspberry Pi here, 3.3. Then it goes to the VDD of the converter here. It also goes to the plus of the potentiometer, and then the ground also goes to the ground of the converter here. It also goes to the ground of or minus of the potentiometer there. And then the out of the potentiometer here, where I'll be reading off the voltage value, goes to the channel 0 of the converter there. So you can also see it directly here on my, I think I can expand this a little bit. There, so I have the potentiometer over here. I have the plus and the ground there. And then I have the plus, the 3.3 volts here on this line. And then I have the ground on this line. Then I connect those VDD here to 3.3, ground here to ground. And then here is the potential out of the potentiometer that goes to channel 0 there. And then I have my SDA and SCL lines that go to GPIO2 and GPIO3 here on the Raspberry Pi. Supply here, or 3.3 here, and then the ground here. So that is the setup as I have it over there. Okay. So like I've said, I've already developed the driver for this particular device. driver is composed of two main components. We have a library, which contains the function block that runs the logic there. And then there is what we call a device description, which basically defines the device. And then with that description, then you can add the device on the device tree or on the particular interface that you want to work with. So first thing, I'm going to install both. I'm going to install the library. I'm also going to install the device description. And then we can see how those two really collaborate. So first thing, I'm going to install the library. So I'll double click here, library manager. All I need to go is to go to library repository, and then I say install. Then I should browse where I have my library. So I have my library here that I've already developed. So I can just select that and then click open. And that should install the library in my Codesys environment. And then as you can see, the library is over there, ADS1115 underscore ADC, and then it's version 0.0.0.2. And then the next thing is to install the device description. To do that, I go to my tools here, and then I go to device repository. Then I click this install button here, and then I browse where I have my device description as well. You can see it's over here. Then I click open or install, and then it will install it in my, installs it under miscellaneous here. So you see I have a new device here called ADS1115 ADC. And the description here says ADS1115 analog to digital converter. And that's it. Now I have everything that I need. Now, if I go to my I2C master here and I attempt to add a new device, I should have the new device that I just added there on the list. So it's right there. Then all I need to do is to add the device just like that. And then I close this. Now, before we continue here, there's a few things you have to note again. First of all, you need to make sure that the I2C interface is enabled on your Raspberry Pi. That's number one. And then number two is to make sure that the device you want to connect to is detected on the I2C bus. So I will pull up my PowerShell here. And what I want to do is I want to connect to my Raspberry Pi over SSH. So I'll say SSH pi at 192.168.1.37. As for the password, I'll enter that as well. Oh, I think I missed something there. Okay, now I'm connected to the Raspberry Pi over SSH. Now you want to run as sudo rasp-config, and then you want to go to interface options. So interface options. Then you want to go to I2C, and then it will ask you, would you like ARM I2C interface to be enabled? You click yes, and then OK, and then finish. So now we've enabled the I2C interface. Now we can attempt to detect to see whether our device has been detected on the I2C bus. So I will run this I2C detect command. So I2C detect -y /1. And as you can see there, we have our device address 48 there. So that means things are looking really good. We have our I2C enabled, and we have our device detected also on the I2C bus. Okay, so now we know that our device has been detected, and all is good there. Now we can attempt to communicate with it. So I'll come here in my program. So this driver defines 4 channels, just like the channels on the converter there. So we'll declare 4 variables to represent each channel. So channel underscore 01 of type rare, and then I will define the other 3 as well. like that. And those are the 4 channels there. And now to access or to read data from the device, so I will call the device by name here as is displayed on the I2C on the device tree here. So for channel 0, for example, I will call the device name here. So ADS1115, sorry, that's caps, 1115 dot, underscore dot, see this channel data, that's the buffer where the data is stored. So it's an array of 4 elements, each representing 1 channel, 1 analog channel there. So for channel 1, I want to read the buffer at index 0. And then channel 2, I'll do the same. So channel 2, I want to read at index 1. So this is channel 2, channel 3, and then channel 4. Like that. Okay. So when I run this program, I should be able to read whatever data is stored in these buffers. And it buffers towards data that is read from the corresponding channel there, analog channel. Now we had this visualization as well. We can as well add something here. So since we are connected to only 1 channel, that is channel 0, we are going to add just 1 rectangle here, and we should be able to see the data that is coming in here. So I will so this is %f, and the text variable here will be, we can browse, and we want to display channel 1 basically. So the data that is coming in each channel is scaled by 1000. So to get the real value, we have to scale down this by 1000. So we have to divide this by 1000 so that we get the real value there. Okay, so we should see data here coming in channel 1. And by the looks of it, I think everything is now set. I will, of course, generate code here, make sure I have no errors. Wait for that to complete. Okay, no errors. So now I can upload my program here. So log in. Yes. Okay, put this to run. And now we are running. Okay, so as you can see right away, we have some data here, but this is scaled by 1000. So this is almost 0 there. If we come here in our visualization, we should see that we have almost 0. So you see we have 0.8. Now, I will make this one a little bit bigger, maybe around there. And now, so if I now start changing the potentiometer here, we should see the values changing there. So if I go this side, so now it's decreasing. Now it's almost all the way to 0. Now if I start increasing, then it should start increasing as well. Remember, the maximum is 3.3. So there we have 3.2.3. And then if I start decreasing again, it should start decreasing all the way towards 0. That is 0 volts, and then the maximum is 3.23, 3.3, around 3.3 there. And so it's the same thing here. So you can see in the program here, we are only connected to channel 0. So that's why we are seeing the data change. Now it's all the way down. And then if I start increasing again, it should start increasing. There. We could switch this to any other channel and it should be the same. It's a pity that we only have 1 connection, but now you can see channel 4, the same thing. So now it's 0 all the way. Now it's start increasing, and then it starts to increase there. Okay, so now we are reading the 4 channels from the I2C device there, and everything is working as expected. If you need this driver, I'll leave a link in the video description to the GitHub repo where you can get the driver and also use it in your own projects. It's really a simple driver. It's not anything complicated. One thing we didn't look at is this driver is there is a configuration parameter here. So this is an equivalent. So this is in decimal, but the equivalence of this in hex is 48. So that is the default I2C address for the device here. But if you have up to 4 devices, that means each device will have its own I2C address, which is not the default address, of course. So you can always change the. Oh, I need to log out, I think. You can always change the address of the device from here. So the default value is 72, but you can always change it to any other value that you want. So you can change it to 73, for example. 73 in hex will be, of course, it's not 48 anymore. So that would be a 49. So if you have your devices on 48, 49, 50, 51, so you have 73, 74, 72, 73, 74, 75. But the default is 72 because we are using the default for address, which is 48 in hex there. Okay, that's it for this video, I guess. We shall be looking at more topics in the coming tutorials as well. And thank you and have a nice day.